A wise man once said, "Chemistry itself understands that the fear of scarcity of global resources may threaten mankind. We must value its importance and understand that without chemistry, life would not be." But what is chemistry, and why is it so important? The simple knowledge of knowing what the world around us is created of is important to understand daily life. So I asked a group of teenagers the simple question, what is chemistry?
As like the chemistry of the class or chemistry between people?
No, like what is chemistry?
The study of chemical matter, chemicals, how they mix together.
Stuff between people, sparks between people.
Chemistry is sparks between people?
Yeah.
Do you know any other type of chemistry?
The chemistry in science, I think.
Do you know anything about that?
I know that it has to do with science and atoms and molecules and matter and that stuff.
Chemistry, noun. The science that deals with the composition of properties, substances, and various forms of matter. Basically, chemistry is the study of the makeup of everything and anything on Earth. It is much more than an experiment or a reading in a textbook. It is much greater than an explosion of a Coke bottle or a fire. Chemistry has the explanation for almost everything and every life on Earth. It is the reason our knowledge for life as humans is greater than it has ever been. Part 1. States of Matter. Chemistry is made up of different states of matter. A solid is a state of matter in which molecules are compacted together, making the object hard. Solids hold their shape and keep the volume. Some solids include diamonds, rocks, and ice. Liquid molecules are slightly more separated, making the ability for liquids to flow easily. Some liquids include water, blood, and milk. Gases consist of molecules that are separated and that move fast. Gases assume the shape and volume of their container, are compressible, and flow easily. Some gases include oxygen, steam, and toxic smoke from factory plants. The last state of matter is plasma. Plasma is a hot ionized state that is made up of electrically charged particles that are strongly influenced by magnetic fields. Some examples of plasma include lightning, auroras, and the sun. Everything is matter and is either a solid, liquid, or a gas. Matter is anything that takes up space. All solids, liquids, gases, and plasmas are examples of matter. Part 2. Physical and chemical changes. In a physical change, the substances are not altered chemically. No new products are formed, and chemical bonds are not broken. A physical change can affect the size, shape, or color of a substance, but does not affect its composition. The substances may be changed to another phase, separated, or combined. Physical changes include cutting a piece of paper and mixing oil and vinegar in a salad. In chemical changes, the substances are altered chemically and display different physical and chemical properties after the change. When a chemical change occurs, new substances are formed through a reorganization of atoms. a chemical change is irreversible. Examples of chemical changes are burning of a log wood and nail rusting. Part 3. Scientific method. Have you ever wondered how scientists make discoveries? Is it simply serendipity, or is there a specific process in which scientists go through to research and find results? The scientific method is a method of research in which problems are identified, data is gathered, a hypothesis or educated guess is formulated from the data, and the hypothesis is tested. The scientific method has helped researchers find discoveries such as plastics and radioactivity. Step 1. Ask a question. What is it that is concerning the scientist? Identify the concern and question at hand. Step 2. Make observations. Observe the surrounding areas of the conflict. Step 3. Propose a hypothesis. Make an educated guess on the solution to a problem that answers the questions from Step 1. Step 4. Design an experiment. Design an experiment that properly tests the hypothesis. Step 5. Experiment. This is where the hypothesis will be tested. Step 6. Accept or reject the hypothesis. This is where you will test your accuracy and see if your experiment correctly tested and found the question to the answer. If unsuccessful, repeat Step 5 and retest the hypothesis. The scientific method has helped and continues to help scientists make discoveries. It is the main process in which we as humans can ask questions, experiment, and answer the unknown. Part 4. Chemical reactions. A combustion reaction occurs when a substance rapidly combines with oxygen to form one or more oxides and releases energy. CH4 plus 2O2 becomes CO2 plus 2H2O. A synthesis reaction is when two or more molecules combine to form a single product. H2 plus Cl2 becomes 2HCl. In a decomposition reaction, a compound breaks down into two or more simpler substances. CaCO3 becomes CaO plus CO2. A single displacement reaction is when one element takes the place of another in a compound. Fe plus CuSO4 becomes FeSO4 plus Cu. In a double displacement reaction, the positive and negative proportions of two ionic compounds interchange. AgNO3 plus KCl becomes AgCl plus KNO3. Part 5. Table of elements. The periodic table of elements. The periodic table of elements consists of 117 elements and can be broken into 8 parts. Nonmetals, alkali metals, transition metals, alkali earth metals, rare earth metals, and other earth metals, halogens, and net elements. Each element has an atomic number and atomic mass number. The elements are sorted by their atomic number. There are 6 periods going from left to right. There are 8 groups going from up to down. The periodic table can also be put into groups when finding the electron configuration SPDF orbitals. All make up the periodic table of elements and each equal different amounts, S equaling 2, P equaling 6, D equaling 10 electrons, and F equaling up to 14 electrons. Part 6. Chemistry in Daily Life. The main focus of chemistry is the importance in our daily lives. From cooking to cleaning to understanding how everything is produced. Humans' 3 basic needs, food, shelter, and clothing, are made up of chemicals. Therefore, without it, our basic needs would not be fulfilled. Some daily products used with chemicals are gasoline, household cleaners, makeup, and processed foods.
There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercurium, molybdenum, magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard, and there may be many others, but they haven't been discovered.